1. Okay, here's the video for rotating a conic section with Geogebra. Geogebra has this cool tool right here called Rotate Object About a Point by an Angle. What you need for this, though, is a point and an angle to rotate it about. Okay? And you'll actually enter the angle when you find out the point. So let's try and rotate it about some point. So we need a point out there somewhere. There's our point, A. Okay? And it's a free point. That's good. And now we're going to try and rotate. Notice it's not at the center of the conic section. It doesn't have to be. Now, if we try and rotate a point about, rotate a thing about an angle, we go to this rotate thing. Where'd it go now? There it is. Rotate. We select this object. We select this point, and nothing happens. Okay? Select object to rotate, then center point, and enter an angle. See, it wouldn't let us do that. Let's try it again. Select the object, select the center point. Oh, and there's the rotation. Rotate counterclockwise?
Yeah.
Okay. Oh, it did it. All right. So it can be done. Do you see how to do it now? Okay.
Wait, but the thing is, like, if you were to have a hyperbola, like the two hyperbolas, and then I rotated on the vertex.
Yeah.
But then I can't find a second vertex. Like.
Right, because this is a C prime. See, this is. Oh, though it actually gave the equation with this, didn't it? And notice how it's got this XY term in it now?
Yeah.
Because it's a twisted conic. And also, we should be able to move this A around. And oh, hello. It's rotating a little differently, isn't it? In fact, we can try and put it there. We can see it's rotating 45 degrees.
So you don't need the roller.
So I guess you don't need the procedure I mentioned in there, but it's a good backup procedure. Because notice the first time we tried that, it didn't seem to respond well. But now it does. Okay.
Try it with hyperbola.
Yeah. Can we try it with hyperbola? Sure, let's try another one. We can do this. We can just change this formula. And what's the hyperbola you're saying?
Let's do the one that we have.
Yeah, what's the original one? XY equals 16.
So it'd be y equals 16 over x.
XY. No, you can just XY equals 16. You should like that.
It doesn't. It just gives like a slide.
Invalid input. Fine. We'll say y equals.
16x.
No, it should do XY equals 16. No. Okay, stand corrected.
No, maybe.
Y equals 16 divided by x. Boom. What?
If it got moved the. Oh, I'm just kidding.
What?
Never mind. I don't know what I'm saying.
Oh,
Maybe
no, 4 should be a point on it.
Yeah.
Why isn't it graphing now?
Maybe close.
We're going to edit out this section of the video.
Okay.
This is where things just went awry.
Maybe
Oh,
open
come
a new
on.
one. Or
Are you sure I can hear you from over here, the microphone?
Yeah, let's just do new window.
Okay.
XY equals 16.
okay.
What? Oh, yeah, it's there now.
Oh, it's just hidden.
There's a slider. I did that too.
What? Oh, it's thinking that x times. Okay, you know what the problem is? I'll tell you what the problem is. New window. You can't just say xy. You have to say x times y. Otherwise, it looks for a variable named xy. There you go. Oh, to be sure. Okay, so there's our x times y equals 16, right? And now I think we want to change the scaling a little bit so we can see it better. There, how's that? Is that the same scaling you got on yours?
It's up to
Yeah,
20 on the.
You want 1-to-1 scaling? No.
Yeah.
Oh, it goes up to like 20? Okay. Trying to get them both roughly the same. That looks pretty good.
Yeah.
Okay. Now let's try and rotate this. I think though we need. We just want this a little thicker, if you don't mind. Make it a little thicker. Okay. Now you want to rotate about the origin. Well, we better have the origin specifically as a point. 0, 0. Make sure you got that point in there. We got something to rotate about. And now we go to our rotate thing. Select 3. No. Rotate right here. Rotate object about
It's under, right there.
a circle.
It's about
That's reflect.
that one.
Oh, reflect. Rotate object about a point by an angle. Okay, so the three things. We have to select the object, the point, and now 45-degree rotation. Sound good, or 90?
Yeah, 45.
It's 45?
Yeah.
Is it counterclockwise or clockwise?
Counterclockwise.
Bam! There you go. Not only that, it's giving the equation of the rotated object over here.
So then would you use that to find the vertex, the asymptote?
Well, now that it's rotated, and you can see that it is a standard hyperbola now. It's not a rotated hyperbola because there's no x times y term. So I think you can see here that you can find this distance. If you know where these vertices are, they're going to lie in this axis y equals x, right?
Yeah, like I found the vertex.
So it's going to be a 4, 4, and negative 4. So it's 4 square root of 2 away, right?
Yeah.
So this should be 4 square root of 2 away as well.
So I rotated at a 4, 4, and then I got this one.
Thank you, Alex.
I got this one was vertex at 4, 4 somehow.
Yeah, this vertex is at 4, 4. Why? Because
when I rotated this, I got this. This vertex is at 4, 4 too. I don't know.
it's not at 4, 4. No.
Maybe
No.
I think I did it wrong.
Y equals x is the original axis, one of the transverse axis on this graph, right?
Yeah.
And let me clean this up a little bit because it looks a little distorted there. Now I've got my axes the same length, okay? So that's that. Now we could rotate this axis, the symmetry gets rotated as well, and it'll rotate right onto the y-axis. So if you look at that distance, find the crossing of these two. Crossing, point crossing, there we go. Boom, shaboom, boom. See those? Let's find that distance. Measure. To measure is to know. A distance from here to there, 5.66. That's 4 square root of 2. Okay? And so when you rotate it up, they're going to be straight up, so that'll be at 0, 4 square root of 2. All right?
So how do we know the vertex is that?
Because this point here at C is also getting rotated 45 degrees. It ends right there. Yeah, this is the original hyperbola. And in black here, let's make this our transformed one. Let's make it red. There you go. There's the rotated one. And you've got the equation there too, in kind of a strange form, but as you can see, if you multiply through by 2, you'll get negative x squared plus y squared equals 32.
And then
Okay.
you can find asymptotes.
Right. Now, the asymptotes were originally the x and y axes. Those have been rotated as well. Right? Okay? All right. We're going to stop now. Stop recording. Thank you. That was 8 minutes, but we're going to take out the part where we kind of went, whoa.